Now let's pay our attention to the first law of thermodynamics. Now first law is basically a law of conservation of energy. This means that the energy is conserved in every operation that a system performs. Now we'll talk about two kinds of system. One system that is undergoing a cycle and the other system which is undergoing a state change or a process. This means that the first law has a different expression for a system which is undergoing a cycle and for a system which is undergoing a process. But the essence is same for both of them. That is, the energy is conserved in both the cases. So let's begin by looking at the first kind of a system that is undergoing a cycle, and let's pay our attention to this diagram on the screen. Now, this diagram is plotted between two arbitrary properties, property x and property y, and it is showing a system which is undergoing a cycle, that is from 1 to 2 and then again back from 2 to 1. Alright, so let us say in going from 1 to 2 we transfer some heat, we transfer some work to the system, and that is, let us say, W12. And in coming back from 2 to 1, let us say the system throws out some heat, that is Q21. Okay, now it is found that this W12 would always be proportional to Q21. So this would be, this comes out to be a known fact that whatever work you put in, the proportional amount of heat would come out. Okay, and this proportionality sign can be removed by an equal to and put a proportionality or a constant of proportionality, that is J, and this J is known as the Joule's constant. This is known as the Joule's constant. Now this is a value which is a single value, so this means like this a lot of heat and work quantities would be there. So if you have a lot of heat and work quantities going in and out of the system while the system is performing a cycle, we take a cyclic integral. So the cyclic integral of the net work transfer of the system is equal to J, that is the Joule's constant, into the cyclic integral of the net heat transfer of the system. So this is your first law of thermodynamics for a system which is undergoing a cycle. Okay, now let's look at the second system that is undergoing a process. So let's talk about that. Now let us say we have a system which is undergoing a process. So in this process has both heat transfer taking place. So heat transfer is also taking place in this process. Alright, and the work transfer is also taking place in this process. Now is it to or from the system? Let's not define that, but in general, heat and work are both involved in this particular process for this particular system. Okay, so when you have both of them occurring in a system which is undergoing a process, alright, the net energy transfer, let me write down this word, the net energy transfer. Now where does this go? Or the net energy, where does this go? This is stored or accumulated within the system. So this is stored or accumulated within the system. Alright, and this energy or the net energy that is stored in the system is called internal energy. It is called internal energy. Okay, so let us say that Q is the amount of heat that is transferred to the system. So this is heat to the system. Okay, and let us say W is the amount of work that is transferred from the system. So this is work from the system, and both of them are during the process that we are talking about. So in this case, the net energy transfer, the net energy would be equal to Q minus W. So this Q minus W is the net energy that is stored in the system. Now this energy, this net energy, this is neither work nor heat. Okay, and the name of this net energy is given to us as internal energy, or simply energy of the system. So Q minus W is equal to delta E. This is the first law of thermodynamics for a system that is undergoing a process. So this is the mathematical equation that is governing a system which is undergoing a process, and this mathematical equation is for the first law of thermodynamics. Okay, so this means that we have two equations. The first equation is for a system undergoing a cycle, that is the net work exchange in a cycle. This is equal to the net heat exchange in the same cycle. And the second is the net heat transfer is stored within the system, or this can also be written as Q is equal to W plus delta E. So this is the second equation of the first law of thermodynamics. So both of these equations, they basically telling us that the energy is conserved. So the energy conservation is always there. The energy is conserved in these operations, whether a system undergoes a cycle or whether the system undergoes a process. Now, the first law then is a particular formation or particular formulation of the principle of the conservation of energy. Okay, but this definition does not give us an absolute value of energy. You can see that we have a delta E. We are always getting a change in the energy. We are always having a change in the energy, but not the absolute value of energy at a particular state. So we have the delta E for the process. We don't have E for a particular state. So this means it can be shown that energy has a definite value at every state of a system, and therefore it is a property of the system. Okay, so I'll repeat my words that in the definition of the first law, we are only getting, so the first law is only giving us the change of the energy, but energy is the property of a system. Energy is the property of a system, that is, energy has a definite value at every state of a system. Okay, but first law is not able to give us the value of energy at every state. It is only able to give us the change during a process. Alright, so in the next video we'll talk about this, that is, we'll show that the energy is the property of a system. So we'll talk about this in detail in the next video. So I hope you understood this particular introductory video on first law of thermodynamics. Now let's move on to the next video and talk about or show that energy is actually the property of a system.